Hello, this is the second of two recordings on partition analysis or cart modeling using the JUMP software. Again, before watching this video, you should have watched part one and you should have read the instructor notes on partition modeling in JUMP. So we're going to talk about using partition modeling to analyze a data set from the printing industry. So there is a printing process, and this is a high volume printing process called Rotogravure Printing. It's a very old, very economic method, and the basic idea of this type of printing is there's what's called an impression or gravure cylinder, and whatever the image is you want to put on paper, it's on this roll, and the roll goes through an ink bath. A blade wipes off excess ink, and then the image is impressed upon a piece of paper. And this is how, up until actually not that many years ago, how most newspapers and magazines were printed. It's rapidly being replaced by digital printing, but it still is viable and is still widely used. So that's the basic idea of it. And what happens is that roll that contains the image, sometimes it'll begin to wear down and grooves occur in it. So wherever there are grooves in the gravure cylinder, the doctor blade can't wipe the excess ink off, and you end up getting streaks down the paper. So if you've ever actually seen a newspaper or a magazine where there were ink stripes going down the page, that's what's called banding. It's a serious defect. You have to stop the run, you have to fix the cylinder, and this can take up to 6 hours and can just destroy your cycle time and destroy your production scheduling. So a team has gotten together to try to isolate what might be causing variation, what's causing the banding. Not all runs have band, some do. So they've put together a data set on 560 press runs, and they recorded a nominal variable or categorical variable. Band either occurred or it did not. They also recorded 11 categorical variables that could be predictors and 18 continuous variables that could be also be predictors. This data is very messy, so we will not do it in this video, but before using the data, you should do things like a missing value analysis. You'll discover there's a variable called ESA voltage that's 98% missing, so we would discard it. You would also discover lots of problems with the alphanumeric variables, with abbreviations and misspellings, making one think there are far more categories than actually exist. So at this point, what I'm going to do is go ahead and walk through an analysis of this data and give you more exposure to the use of the partition platform in JUMP. So these are the variables. Some of these are not useful, and I won't get into details. Job number is just a job number. It's not terribly useful. Remember, our goal is to find out what is most likely the cause of banding. Customer is interesting. If you go down through this data, you'll discover, unfortunately, and I'll give you an example. I'll highlight a few here for you. Notice this customer, National Wildlife. Well, it turns out, unfortunately, it's been spelled different ways depending on who entered the data. So if you wanted to use customer as a predictor, you would have to go through and do extensive recoding of the customer column, which we will not get into because it will take some time to clean it up. The variables that are of interest are from grain screened, okay, over to chrome content. the variable ESA voltage will be ignored because it's 98% missing. There are lots of other variables with missing data, but they're all in the range of around 50%. So we're going to use all the other potential predictors. Again, this is an analysis you should do in advance. This idea of exploring the data, look for problems, clean up problems, look for excessive missing values, and so forth. So I'm going to go again to Analyze, Modeling, and then Partition. Okay. Our response is band occurred. Okay. And I'm going to put in all the potential predictors from grain screened down to solvent percent. Remember, we're skipping ESA voltage, and then wax down to chrome content. Okay. Now notice at the bottom there's something called the missing, informative missing. Do check that off. It's possible that some of the missing values that are occurring in this data might actually be informative. There used to be an idea that missing data was simply missing and it didn't matter, but we're discovering often the missing data patterns are non-random, and there may be a good reason why they're actually missing. So if you check off informative missing, JMP is going to actually in the background create an indicator variable which will actually be added to a potential predictor, and the indicator variable is a record is a 1 if it's missing, a 0 if it's not missing, and then it'll see if whether or not observations are missing actually explains a variation between runs with band occurred and band did not occur. We will not use what's called a validation portion. If I were to use it, I would, for instance, put in a number like 0.3, and what JMP would do, it would take at random 30% of your data, set it aside, build the partition model on the other 70%, and then test that model on the validation portion. So validation is one of the key ways that we can assess how well our model works. So for this example, I'm just going to use all the data and I'm not going to hold any of it back. So once we're in the report window, go to the main report menu to the left of partition. Under display options, select show split probabilities. Okay. So notice in the original data about 58% have no banding, 42% have banding. And at this point we look for potential variables, candidates to split on. And notice this is interesting. JMP is selecting ink percent, but solvent percent is almost as good if you look at log worth. And we'll come back to this because these two variables are actually very similar in how they behave with respect to banding or banding not occurring. So we're going to go ahead and let JMP pick the split. So I'm going to go ahead and split. And sure enough, if the ink percent were greater than 64.1, and now this is key, or missing, keep this in mind, I'll come back to it, 99% of the runs had banding. So before we jump for joy because we've figured out the cause of banding, when using partition analysis, never ever jump to conclusions. So basically on the left hand side, if the ink percent were over 64.1% or missing, don't ignore that, then it's entirely possible that banding occurred. So let's try another split. Okay. It's split on the right side. On the right side are all the runs where the ink percent was under 64.1. Notice what it's telling you. If the press speed was greater than 2,189 feet per minute, or missing. What jump is doing, it's telling us these missing values that are occurring in the data may be very informative. In other words, they're not just random. There may be reasons why these observations were missing. Notice, 91% of these runs did not have banding. So let's try another split. In fact, I'm going to go ahead, and I'm quite familiar with the data. I'm going to go ahead and do 8 splits. Okay, there's no right or wrong answer to how many splits. In general, when you get in the range of 8 or 9, you've basically found, you'll usually find most of the structure in the data, and in other words, relationships that might exist to banding, and after that you're just splitting on noise. So notice our tree is getting a bit unwieldy. So I'm going to go to the report menu, and there's something called a small tree view. So this gives you an idea of the different things we were splitting on. Okay, and again, notice the missing values seem to be an important issue in terms of prediction. And the leaf report. So this gives you all the pathways to the terminal nodes and the classification of banding and no banding that occurred in those nodes. And then there's something else that's important, column contributions. What this is doing, it's saying in all the splits, here are the variables that contributed most to the correct prediction of banding or no banding. And you can see they're sorted. 8% press speed. Press, by the way, is not useful. That's an asset tag or just an asset number. I could have left it out. I included it, but the subject matter experts would probably tell you to remove it from the model because press doesn't really tell them anything about potential cause. And then finally, there's another plot that's useful, and it's called show fit details. Okay, so this gives you what's called a confusion matrix. So on the rows, these are the actual conditions, and this is what the model predicts. So there are 208 runs where my model predicts banding, and there is banding, but there are 19 cases where I predicted banding but there wasn't. So the 19 misclassifications. And then for no banding, here's where we really get in trouble. There were 119 runs where the model predicted banding but there was no banding. So if you look at the diagonals, these are your overall misclassification rates. Okay, so not necessarily a good model, especially when we've incorrectly misclassified roughly 120 cases as banding where no banding actually occurred. So this is the basic idea of how to use the partition platform. And frankly, if you want to, you can split back. If you want to prune back and resplit, so I'm going to prune back just as an illustration. Okay. I'm going to illustrate one more concept to you. So I'm going to prune all the way back. And then I'm going to go to so I'm back to 2 splits. I'm going to go to the partition report menu. And notice where it says lock columns. If you find something getting into your model, a variable that's not of any value to it, or for some reason the software keeps repetitively splitting on it, it's a good idea to lock it out. Once I lock this variable press out, it cannot be used. So I'm going to go ahead and split again. Again, press has absolutely no information. It's just a tag put on the machine by the accounting people. So again, I'll do 8 splits. Okay. There we go. And by the way, there's your tree. And notice that all of the um, displays that you have will update. Okay. So notice we really haven't done very well with the confusion matrix. There's still a lot of misclassification, but at least from the column contributions, it's giving us an idea of where to look. Now I mentioned one needs to be careful about ink percent because remember in our split, what it split on was ink percent or missing. So I'm going to go back to the data table and let's scroll down towards the bottom. Okay. And I'm going to focus on ink percent and solvent percent. Notice all the missing data. In fact, we're going to scroll up. Okay. So from press run 486 down to the final press run, there are 55 runs. Ink percent and solvent percent are missing, but notice something else. And this is why it showed up in the model. All of these runs showed banding, so that's why it split on ink percent and said greater than 64.1 or missing. So right now this is enough information to basically question the usefulness of this data. Why are the last 55 runs all missing ink percent and solvent percent and 55 in a row had banding? So before I would go much farther with this data, I would ask a lot of questions. So partition modeling is very powerful, but that still you as the analyst have to dig into the data, particularly when you find out that you have informative missing data. So in this case, that informative missing data told us, hey, there's something wrong in this data. And it was up to me to explore the data and discover why ink percent and solvent percent got in. They're missing. So basically, a word of caution, do not jump to conclusion when using this method, but used judiciously and carefully, it can go a long way towards helping you find risk factors or causal factors in a system.